And welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems is at smarturl.it/pass actuarial exams. Here's information about online seminars for exams P, FM, IFM, and LTAM that I teach, and the study manuals for those exams that I wrote. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's problem number 1 from the written answers section of LTAM exam given in October 2018. You are performing a profit test on a $50,000 fully discrete 10-year term life insurance policy issued to a healthy life age 60. The annual premium is waived when the insured is sick. You are given the following information regarding the reserve basis. A Markov model with 3 states, healthy, 0, sick, 1, and dead, 2, is used to value the policy. The annual probability transition matrix for an insured age 60 plus K for K equal to 0, 1 through 9 is, and you see the matrix, and what we see is that the middle column of transition into state 1 is the same for every K, but the first column has transition from state 0 to state 1 depending on the age of the form 0.90 minus 0.01 K, and then from transition from state 1 to state 2 in the form of 0.70 minus 0.01 K, while transition from state 0 to state 2 is of the form 0.05 plus 0.01 times K, and transition from state 1 to state 2 is 0.10 plus 0.01 K. Note that state 2, of course, is absorbing. The annual gross premium is $5,000 from the start of the third year. Premiums in the first 2 years are lower, but they're not given. We just know that they're lower. Reserves are calculated using the gross premium reserve method. And we continue. Issue expenses are $300 per policy. Maintenance expenses are $150 incurred at the start of each year, including the first for all policies in force. The interest rate is 6%, and we have actuarial present value functions calculated at I equal to 6% for capital A02. So it's an actuarial present value of a one-time payment for an insured who is in state 0 right now upon entering state 2, which is death, so this is life insurance basically, at various ages for 10 years in terms of starting 10 years of when the policy is valid basically. And then A12 is for an insured starting out in state 1 upon transition into state 2, one-time payment. So life insurance, but for a sick person. A00 stands for an annuity, which is payable for somebody who is right now at the beginning of this annuity in state 0, but the annuity is paid only if the insured is in state 0. So the first 0 refers to the current state, and the second 0 refers to the state in which the annuity is paid. Then A0001 is the same type of annuity, but it's paid when the person is in state 1. A0010 is for a person who is now sick, and the payment comes when the person is in state 0. Note that all of these annuities only apply to the 10 years when the policy is valid. So starts at age 60 plus K and ends 10 minus K years later, so that will be within the 10 years of the policy. A.10 refers to an annuity for a person who is sick now and paid while the person is healthy, and A.11 for a person who is sick now and the annuity is paid while the person is sick. Part A asks us to calculate probability of 60-year-old now within 2 years, starting out in state 0, transitioning to state 1. For Part B, Part 1 of Part B, we need to show that reserve at time 2 for a person who is healthy is 420 to the nearest 10. You should calculate the value to the nearest 1. Part 2 of Part B asks us to calculate reserve at time 2 for a person who is sick and show that 2v1 is 8,880 to the nearest 10. You should calculate the value to the nearest 1. And then you are given that 3v0, so the reserve at time 3 for a person who is healthy is 1,788. Calculate the reserve for a person who is sick at the same time, so at policy duration 3. Furthermore, you are given the following additional information regarding the profit test for this policy. The earned rate is 5.7%, the hurdle rate is 8%, pre-contract expenses are 200, maintenance expenses are 60 at the start of each year, including the first for all policies in force. Mortality and morbidity are the same as in the reserve basis. There are no withdrawals. The profit signature values for t equal to 1, 2 are pi 1 equals 84.74 and pi 2 equals 80.34. For Part C, we need to show that pi 3 is 70 to the nearest 10. You should calculate the value to the nearest 0.1. And Part 2 of Part C asks us to calculate the discounted payback period. So here's the solution. As I said already, state 2 is absorbing, while states 0 and 1, so healthy and sick, communicate with each other, and this is the graphical representation of this model, multiple state model or Markov process model. For Part A, we calculate 2p60 upper 0, 1 using information about transition probabilities at age 60 for k equal to 0 and age 61 for k equal to 1. So these two matrices are the transition matrices at age 60 and 61, where we just plug in k equals 0 and k equal 1 to the formulas given. And then 2p60 upper 0, 1, well, how do you get from state 0 to state 1 in 2 steps? Either you go from state 0 to state 0 and then from state 0 to state 1, or you go from state 0 to state 1 and then from state 1 to state 1. And you can't go through state 2 because state 2 is absorbing. So this probability is equal to p6000 times p6101 plus p6001 times p6111. And we just look up those values in the two matrices I wrote out for you, and they're 0.9 times 0.05 plus 0.05 times 0.20, and then we calculate this and we get 0.055. For Part B, Part 1, we are calculating 2v0. This reserve is kept at time 2 if the insured is in state 0. The company receives 5,000 at the beginning of every year, starting with year 2, and we're looking at that moment in time, year 2. When the insured is in state 0, note that this accounts for waiver of premium state 1, because there is no premium paid then, so that's the only time to get the premium is if the insured is in state 0. And the company pays 150 in expenses while in state 0 or 1, and benefits of 50,000 if the insured is in state 2, and note also that state 2 is absorbing, so it effectively ends the policy. So, therefore, 2v0 is present value of these death benefits, 50,000, times A62 colon angle 802, because During the 10 years of the policy, a death benefit of $50,000 is paid if the person transitions to state 2 and the person starts out in state 0, because we're doing calculation for a person who is in state 0. Plus the expenses, $150, that are paid as long as the person is either healthy or sick. So as long as the person is alive. So that's why we have these two annuities. One is paid while the person is healthy, and the other one is paid while the person is sick. But 150 still has to be paid. So this is the actuarial present value of expense annuities representing expenses. Minus 5,000 times 8 colon angle 800, because the premium of 5,000 is paid only if the person is healthy. All of these numbers can be looked up in the table. We plug them in and do the calculation, and we obtain 417.415. For Part B, Part 2, we calculate in an analogous fashion for 2V1 for the person who is in the state of being sick. Actuarial present value of death benefit is 50,000 times A62 colon angle 812, representing a transition of this sick person to the absorbing state 2, state of death, plus the present value of the expenses annuity. And now the person starts out in state 1, but the annuity is paid if the person is in state 1 or state 0. And minus 5,000 annuity paid as long as the person is healthy, but starting out in the state of being sick over the next 8 years. All of these numbers are given in the table. We just plugged, not in the table that comes with the exam as an extra, the table that is given in this problem. I should have said that more clearly. My apologies. So we just look these up in that information that is given to us. Let me remind you of this table that was given in. Okay, so here it is. This is where we look up all the numbers that we're using in the calculation. So then we plug in all these values from that little table given in the problem, do the calculation, and this comes out to be 8,881. For Part 3 of Part B, we write the recursive formula. So starting, actually two of them, for starting out with a healthy reserve. Then we get the premium, pay the expenses. This is accumulated with 6%, and it pays for the reserve in the healthy state if the person is healthy, plus the reserve in the state being sick if the person transitioned from state 0 to state 1, plus if the person transitioned to state 2, starting at state 0, then a benefit of 50,000 is paid at the end of the year. And if the person starts out as being healthy, then the reserve for being healthy minus 150, there is no premium paid then because the premium is waived. When the person is sick, this is accumulated at 6%, and it pays for the healthy state reserve at time 3 if the person transitions from state 1 to state 0, plus 6 state reserve if the person stays in state 1, plus the death benefit if the person transitions from state 1 to state 2. And the death benefit is 50,000. So we plug in all these numbers, and we get these two equations. And both of these equations now can be used to calculate 3V1. And if we calculate it from the first one, then we get 3V1 as 10,200.40, and from the second one as 10,195.10. Well, it's a bit disappointing getting two different results. However, we're just supposed to calculate it to the nearest 100, I believe. So the approximation is 10,200. For Part C, Part 1, at time 2, the insured can be in state 0, state 1, or state 2. If in state 2, the policy has ended and profit at time 3 is 0. If in state 0 at time 2, profit at time 3 per policy in force at time 2 is, well, the reserve plus the premium minus the expense, which in this case is 60, accumulated at the earned rate of 5.7%, minus the payouts at time 3 were not exactly payouts, because if it's a reserve, then it's kept for the customers, but kind of like the money that needs to be kept, so taken away from profit. So if the person stays in state 0, this is P6200 times 3V00. P6200, of course, is the probability of staying in state 0, plus P6201, probability of transitioning into state 1, times the reserve for being in state 1 at time 3, plus the payout, this time a clear-cut payout of 50,000 if the person transitions to state 2. But we actually know that if we did the calculation of the reserve, the recursive formula for the reserve on a valuation basis under the assumptions of the policy, then we have the formula that you see here, just like what we wrote before, a standard recursive reserve formula. And therefore, we can replace the expression that has those 3 terms on the right-hand side by the left-hand side of this valuation formula reserve we just wrote in the first equation for the profit. So we do that, and now everything in there is given, or we just calculated it for 2V0. So we plug those in, and what we get is 79.33. If the insured is in state 1 at time 2, profit at time 3 per policy in force is, well, this is an analogous formula, but starting out with reserve in the state of being sick at time 2, and without the premium, because the premium is not paid, because the premium is waived if the person is sick. And again, we know from the previous recursive calculation that we had on the valuation basis, so with assumed expenses and interest, this 2V1 minus 150 times 1.06 has to be those 3 terms that are the same in both formulas. So we replace this those 3 terms with the probabilities on the right-hand side by the left-hand side of this valuation basis formula in the formula for the profit. And once we do, everything is known, they're given, plug in the numbers and do the calculation, and we get 68.94. The profit that we're looking for is adjusted for the probability of this getting these profits. So if the person is in state 0, that's we take the probability of that times the profit of being for the situation when we're in state 0, plus the probability of being in state 1 times the profit if we're in state 1, plus the probability of being in state 2 times the profit, but then the profit is 0. And we don't have 2P6000, we just calculated though, just like we did before, calculate 2P6001 from those 2 matrices that we had there, and for the first 2 years. So 2P6000 becomes P6000 times P6100 plus P6001 times P6110, because the person who stays in state 0 either does it by staying there both years or by first transitioning to state 1 and then transitioning back to state 0. Of course, you can't transition to state 2 because once you get there, you stay there. And that's multiplied by the profit in a case of being in state 0, or state of being healthy, plus this probability 2P6001, which we actually calculated before as 0.055, times the profit in case of being in state 1. And now all of these numbers are known, so we just all of these values are known, so we just plug them in, do the calculation, and we get 70.071915. This is 70 to the nearest 10, in fact 70 to the nearest 1. And we now calculate the discounted payback period. So recall that pi 1 is 84.74 and pi 2 is 80.35. And we also just calculated that pi 3 is 70.07. So net present value, taking into account the profits from the first 2 years, Now these pi's are adjusted for the probability of being there, but they're not discounted to time 0, so we discount them to time 0 at the hurdle rate of 8%. For the first 2 periods, that's NPV of 2, and that turns out to be negative 52.65, while NPV of 3 includes the profit from the third year, and this was calculated before as 70.07. We discounted now at the hurdle rate of 8%, and this is positive, it's 2.97, so there is no full payback of the expense of 200 of issuing the policy over 2 years on the present value basis, or discounted basis, but there is over 3 years, and that means that the discounted payback period is 3 years. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.